Okay, so as usual, we start off with how many moles of thiosulfate from the burette were used. So we got the average titra, we got the concentration, very dilute. So in this particular one, we're using river water, so probably not going to be a huge amount of oxygen in it. So we're starting with very dilute, and so we divide it by 1,000, times it by the concentration, and we get this number here, 2.46 times 10 to the minus 5 moles of thiosulfate. Now, if we know the thiosulfate, we try and get all the way to the oxygen. So we've got three equations here to use. We use the thiosulfate to work out how much iodine there is. The iodine came from here. We can use that to work out how much Mn manganese hydroxide there is. If we know manganese hydroxide, we can work backwards to get the oxygen. So to go from thiosulfate to iodine, I divide by 2 because it was a 2-to-1 ratio. To get from the iodine to the manganese hydroxide, I times by 2. As you can see, for every 1 iodine, there are 2 manganese hydroxides. And then to get from the manganese hydroxide to the oxygen, you can see for every 4 of those, you started with 1 oxygen, so I divide by 4. Okay, so that will give me the moles. If I do that to this number here, but basically they two obviously cancel out, so I'm just dividing that by 4. I get this number here. That's how many moles of oxygen in the 25 centimetre cubed sample. So what's that as a concentration then? I'm doing moles over volume, put my 25 centimetre cubed into dm cubed. That gave me that in moles per dm cubed. I want to convert that into grams per dm cubed, so I'm going to times it by 32 because that's the molar mass of O2. And that's in about 1 miles in milligrams. There's 1,000 milligrams in a gram, so I can times that by 1,000 and I get 7.87.